In this last problem of the handout, it's a sample size problem. And we are trying to estimate the mean cholesterol level of monkeys. They would like their estimate to be within 1 milligram per deciliter of the true value, 95% confidence. Previous studies say standard deviation is 5, and we need to find the minimum number required. So let's write down some details. We don't know much. We need N. They give us standard deviation, and I hope you're asking the question, is that sigma or S? If it's S, we have a problem. Right now I'm just going to write standard deviation is 5. But is it S or sigma? You know, if we do a T interval, hypothetically, like we did in the last problem, we have a formula like this. And then if we work this problem, we would say, well, we know ME is this, but I hope you're seeing there is a big problem with this. Because while I need N, that's unknown, this is also unknown because isn't T dependent on N, degrees of freedom? Because of that, this way is impossible. We have to assume that that standard deviation of 5 is sigma, which means we use Z. So this is an approximation. This is not precise. Once again, we're using the best of our resources. That means I am going to use a Z interval where x bar plus or minus Z times sigma over square root of N is the interval. That means our formula is margin of error equals Z times that, and we can plug in. So, up in the paragraph, we see within 1, that's margin of error. We already have sigma. We have 95%. The nice thing about Z is I bet you have that memorized. Z is 1.96. Remember, it's at the end of table B. Go to the very bottom, look for 95% and right above it. All right, let's plug in and solve for N. We know 1.96 times 5 over square root of N. Let's do some rearranging. And we know 1 divided by 1.96 equals 5 over square root of N. A few different ways you can work this. I'm going to square both sides to get rid of that radical. And then we end up getting N to the other side. And then finally divide by that horrible fraction. So last step is 25 divided by whatever this fraction is. And that'll give us our sample size. And we get 9604 means at least 97. Cross that 7 just for Mahmood. Lastly, at the very bottom of the page, we have one last approximation. This is a big approximation. If we know very minimal information, you can approximate sigma by taking the range and dividing by 4. That's once again worst case scenario. We have a lot of those, it seems, in stats. I'll see y'all later. Bye.